So hi, today we are going to discuss regarding the Meissner effect or Meissner effect. I'll just write on the board. Correct. MEISSNER. So this is a 8-mark question. It's going to come for the exam. But before knowing what is Meissner effect, we have to know what is superconductivity. Correct. I think we all know what is superconductivity. Correct? Yes or no? I think you can use the chat option. Yeah. So heard about superconductivity. Yes or no? So what is this superconductivity basically? So to understand that, we have to know something called resistivity. That is the rho. When resistivity is zero, superconductivity in a metal or alloy is achieved when resistivity is zero or conductivity is infinite. We know sigma is conductivity, that is 1 by rho. So if I put 1 by 0, what I'll get? 1 by 0 is 0 into what will give me 1? Not defined, right? That's the reason this is infinite. So sigma is called conductivity. Rho is called resistivity. Correct? So when is superconductivity of a metal or an alloy is achieved? When the resistivity is zero or the conductivity is infinite. Correct? Yes, then only we will achieve what? Superconductivity. So I hope this is clear. If this is clear, then we can go to Meissner effect. Correct? So in Meissner effect, the temperature. Let me just stop this shit. Sorry, due to touch, it has gone. Yeah. So in Meissner effect, we'll be discussing about how this transition is taking place. So the temperature at which the solid attains superconductivity. Solid attains superconductivity is called, it's not Meissner effect, it's called critical temperature, TC. TC stands for critical temperature. Okay, so this transition. Clear? So this is my critical temperature, because there are some terms before you write for the Meissner effect. One of the important terms that the faculty will check out is critical temperature. Okay. Now let's see, coming to the Meissner effect now. Yes. So in Meissner effect, what happens is my semiconducting or superconducting material is kept in a magnetic field. Is kept in what? A magnetic field. And this body, this solid body, has to become perfectly diamagnetic. Perfectly what? Diamagnetic. See, if you don't know what is diamagnetic, in diamagnetic, all the electrons are aligned together. They all are aligned together. In paramagnetic, the electrons are not aligned together. Random. Electrons are random. I hope it's clear now. Correct. To get a perfect diamagnetic, we need what? Susceptibility. I think class 12th, we have studied about susceptibility, right? This term, susceptibility, very difficult to pronounce. And for diamagnetic, it is what? Diamagnetic, it is -1. So these things they'll check in the paper. Okay, the important points they will check. Clear? Yes. So for the Meissner effect to happen, we need what? The diamagnetic should be, in the sense that solid body, that solid metal or alloy should become diamagnetic. The electron should be properly aligned. Is it clear up to this? Kindly use the chat option and let me know. Is it clear? Yes, superb. Very good. So these are the key points you have to write. Now let me take it. So I'll write it down. Then switch off my video for better clarity in writing. Correct. So this is basically what I have to. I have mentioned about what? Critical temperature, right? I mentioned about critical temperature. That is my TC. So the metal should be cooled. 1 second. The metal should be cooled below my critical temperature, below my TC, below my critical temperature. To become what? To become diamagnetic. So this key point you write first. Diamagnetic. This effect is called Meissner effect. I'll just change the color. Yeah. This effect is called Meissner effect. So for the exam point of view, you should write down your definition in bold. And then you write down this. Then there are certain diagrams which I'll share you the PDF. Clear? So one more thing, what we should write. So one more thing, what we should write is, you should have one question. And this thing I'm just preparing only for the exam point of view. That is, what happens now? I told you that it should be below the critical temperature. Correct? It should be the metal temperature or the alloy temperature should be below the critical temperature. It will behave as what? Superconductivity. Superconducting material, or it will go to diamagnetic. So when does it, this will become back to original state or normal state? When I increase the temperature above the critical temperature. When I increase it above the critical temperature, it will be in its normal state respectively. Is it clear? So when the temperature is below the critical temperature, it will become diamagnetic. When it is above the critical temperature, it will behave normally. Like how the solid or alloy was previously, it will behave the same way. So that also we have to mention in the examination, because you have to fill the pages. Okay. So the metal should be cooled below the critical temperature, that is to become diamagnetic. This effect is called Meissner effect. So to come back to its original shape, to come back to normal state. All of these things you should write in caps. Normal state. Then the metal temperature should be greater than critical temperature. Then substance will be normal state. Okay, so write down this in simple words so you will come to know the Meissner effect. Then again I'll go back to our class 12th. The formula, the magnetic induction formula. Magnetic induction formula. Correct? B is equal to mu naught into H plus M. B is nothing but my magnetic field. Correct? H is my magnetic field intensity. Magnetic field intensity. And my M. M is my magnetization. Magnetization. Correct? And I think you know what is mu naught. Permeability in free space. So B is my magnetic field, H is my magnetic field intensity, and M is my magnetization. Correct? So this thing you have to note now. I'll write down it clearly here. B is equal to what? Mu naught into H plus. Yeah. Next thing we'll check is our derivation. Now, what was my condition here? To undergo Meissner effect, the temperature should be less than critical temperature. Correct? Yes. Temperature should be, that is the condition here. I'll just put this in box, that this is the condition, this is the main condition. Yeah, the condition. Let me change the color now. This is the condition. Yeah. So the temperature less than Tc, then my magnetic field is 0. If a magnetic field is 0, this term is gone. So mu naught into H plus M is equal to 0. This term is 0. Okay, this I'm just rearranging it so it will be easy for you. Correct? So mu naught cannot be 0. Yeah, so mu naught cannot be mu naught equal to 0. This cannot be 0. Mu naught has a value. Mu naught cannot be 0. So the only condition for us is what? Which should be 0? My H plus M. My H plus M should be equal to 0. So my H is equal to what? Minus M. H is equal to minus M. Okay, H is equal to minus M. And I told you about susceptibility, right? Susceptibility I have told you. This thing, susceptibility. Susceptibility for diamagnetic is what? Minus 1. Susceptibility is nothing but the ratio of this susceptibility should be what? Minus 1 for man. So you might be, I think you will be clear up to this, but suddenly you'll get confused why I am telling you about susceptibility, right? I told you susceptibility in the beginning only. It should be minus 1 for what? Diamagnetic. Again, I'll take you back to your class 12th. What is my susceptibility formula? The ratio of magnetization M by H. This is my susceptibility formula. The ratio of magnetization to magnetic field intensity. This is equal to minus 1. So now you will come to know this minus M by H is what? If I put this H here, minus M by H is equal to 1. So this is nothing but my M by H is equal to minus 1. So we have to write up to this. If my susceptibility values, if this value is minus 1, then it is perfectly diamagnetic. Then it is perfectly diamagnetic. So these things you have to write it down. Okay, for the Meissner effect. So I hope it's clear. Yeah.